if you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater, but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I am Guna Mathivanan from Offices IAS Academy. In today's video, we are going to discuss about CloudBurst. CloudBurst. See, these are short duration, intense rainfall over a small area. Short duration, intense rainfall over a small area. So, intense rainfall 100 millimeter per hour minimum, when the precipitation should exceed minimum of 100 millimeter per hour in a 20 to 30 square kilometers. So, in an area of 20 to 30 square kilometers, if the rainfall is resulting in 100 millimeters of rain in 1 hour, then we will call that situation as cloudburst. Right? This cloudburst is associated with cumulonimbus clouds. It is associated with cumulonimbus clouds. Now, before going to the cumulonimbus clouds, let me explain you some basic concepts about humidity. Humidity that refers to the level of moisture in the air. The level of moisture in the air. Okay. Now, if you take air, you take an air particle. This is one air particle. Just imagine some air particle I am taking. See, moisture in air means you are able to understand, right? So, the air carries water. The air carries water, that is moisture. Now, assume this is one air particle which can carry up to 1 liters of water. Imagine there is an air particle which can carry 1 liter of water. That much space you have. But assume it is carrying only, or let's say it is carrying entire 1 liter. Or we'll assume it is carrying only 0.5 liters. It has the capacity. Imagine a water bottle. Imagine a water bottle as an air particle. That air particle can store 1 liter of water, but only 0.5 liters of water is present. So we will say the humidity is 50%. Humidity is 50%. It is not 100%. Okay. Now, when there is a rise in temperature, when the temperature increases, the air particle will expand. When the temperature increases, the air particle will expand. Imagine that water bottle expands. Right? So now assume the water bottle can store 2 liters of water. But remember, already we have only 0.5 liters. But it can store now 2 liters of water. Why? Because temperature increased. So air particle expanded. Now imagine if the temperature further increases, now the air particle will become even more bigger. Now it can hold 4 liters of water. But it is having only 0.5 liters, we know. It is having only 0.5, but because of increase in temperature, the air particle became 4 liters. So the learning from here is, when the temperature increases, the air particle size will also increase. The holding capacity of air particle will increase. Keep this in mind. Keep this in mind. Similarly, when temperature falls, what will happen? The air particle size will also decrease. So when temperature increases, air particle size will increase. When temperature decreases, the air particle size will decrease. Right? Now just imagine there is a mountain here. There's a mountain here. And now there is one air particle. This air particle can hold 2 liters of water, but only 1 liter of water is present. Only 1 liter is present, but it can hold up to 2 liters. Now this air particle is hitting this mountain. Okay. Now once it hits the mountain, there will be orographic lift. So the air particle will start moving in the upward direction. The air particle will be moving in terms of upward direction. Now when it moves in the upward direction, what will happen? The temperature will decrease. When the air particle moves upwards, the temperature will decrease. So the air particle size is going to reduce. Now it is 2 liters worth air particles. Once it is lifted, it will become 1.5 liter air particle. How much water we have? We have already 1 liter water. That will not change. 1 liters. Now the air particle is further lifted. Now the size will come down. Now what is the size? The size will come down to 1 liter. Now it is completely filled with water. Now at this stage only, this air particle will become a cloud. At this stage, this air particle will become a cloud, which will be having roughly, it will be holding 1 liter of water. Now assume this air particle is further lifted up. When it is further lifted up, now the size of the air particle is 1 liter. Already 1 liter water is present. When the air particle is further lifted up, the air particle size will be further reduced. When it is further, when the 1 liter water bottle, when that becomes half liter water bottle, now what will happen? All the water stored in that particle, that will start flowing outside because the bottle size comes down. Yes or no? When the water flows down because of friction, it will get broken down into small particles, and that is rainfall. That is the precipitation. When it falls down because of the friction, you will see all the thunders. Right? All thunders you see because of that friction. So, what is the learning? An air particle the size will expand when temperature rises. Air particle size will decrease when temperature falls. So this air particle has 1 liter of water but 2 liters of capacity. When it rises, 2 liter capacity becomes 1.5, 1.5 becomes 1 liter, 1 liter becomes 0.5. Alright, it can hold up to 1 liter of water. Already we have 1 liter of water. When the size further decreases, the water will flow down. And that is what is rain. When the air particle reaches saturation means the air particle has reached the exact amount of water. The air particle has 1 liter capacity. The air particle has 1 liter of water. When it has reached the saturation, the clouds are formed. The clouds will keep floating. At one point, the air particle size will further shrink. The cloud cannot hold the water. The cloud is going to break down into rainfall. This is normal thing. This is how orographic rainfall happens. But now I am giving you a situation. Imagine the size here is not 2 liters. Because of very high temperature, assume the size is 4 liters. Because very high temperature in the ground, the size is 4 liters. Now, assume there is already 3 liters of water. That means the air particle size is big because of high temperature, and for some reason, the air particle contains more than usual amount of water. So what happens? This 4 liters worth air particle, now it has assumed 3.5 liters of water. This air particle is now lifted. It is now lifted even before going to this height. The air particle is now coming to this region. Here only, at this point only, the clouds got formed. When it is further lifted, the clouds will become shrinked. The water immediately flows. Now 3.5 liters of water, the clouds are formed at a smaller height only, and it is going to pour everything in a short region. That results in a situation called as CloudBurst. Right? So, cumulonimbus clouds will be formed during CloudBurst situation. You have to understand, you all will be having idea about monsoon. So here we have equator. During summer season, we will be having the southwest monsoon. So during southwest monsoons, the water from the southern hemisphere will be traveling, that is the wind from the southern hemisphere will be crossing the equator. It will take a right turn and it will bring, that wind will be, southwest monsoon winds will be coming towards the Western Ghats. Now when this comes, southern hemisphere is full of water, that is going to bring more water, and when there is unusual rise in the temperature, then what happens? Already the air particle will become bigger and that has more amount of water. We have Western Ghats here, we have Himalayas here. So these winds will hit the Western Ghats, will hit the Himalayas, it will be lifted up. At one point, the air particle cannot hold that much water, the water will completely fall. That is called as cloudburst. That's called as cloudburst. I hope you are able to get some idea. Connect with your geography, you will understand. What is the clouds associated with cloudburst? Cumulonimbus cloud. You won't believe the cumulonimbus cloud, one single cell can have a height of 12 to 21 kilometers. Imagine a cumulonimbus clouds having a height of 21 kilometers. So 21 kilometers big cumulonimbus cloud, if that drops all the water in a shorter area and short span of time, that is cloudburst. You will see such cloudburst in the Western Ghat region, in Himalayan region particularly, because there only you will have that easy orographic lift. And when the temperature is high and when there is more water in the air, and there is more moisture and temperature is high, when there is a mountain, these are the conducive situations for this cloudburst to happen. And you won't believe, see, when there is an orographic lift, so there is mountain here, air particle comes and hits the mountain, the air particle is lifted. Do you know at what speed this air particle will be lifted? It will be lifted at a speed of 60 to 120 kilometers per hour. At that speed, this air particle will be lifted. Imagine if the air particle is so big. Imagine this air particle is already having lot of water. It will be quickly lifted up. Quickly cumulonimbus clouds will be formed. Quickly it will drop everything. In 30 minutes, cumulonimbus clouds can be formed. The cumulonimbus clouds will float for maximum 1 hour. After 1 hour, the cumulonimbus clouds will completely drop the water in a matter of 20 minutes. In a matter of 20 minutes, just imagine such huge cumulonimbus clouds pouring all the water. Right? The problem with this cloudburst is we cannot predict, we cannot forecast. Indian Meteorological Department can give a forecast of rainfall before 3 days. If it is cyclone, 1 week forecast can be given. Regular rainfall, 3 days forecast can be given. But cloudburst, see how quickly it is forming, how quickly it is dropping. So it is difficult for us to forecast, predict the cloudburst. See, there is one method called as Doppler radar system. Doppler radar system, that radar system can predict the formation of clouds. Okay, the Doppler radar system that can sense the formation of clouds. When a bigger clouds are being formed, the Doppler radar system can identify and can tell us information that a big cloud is getting formed. So be safe. But the problem with Doppler radar system is that is a ground-based radar system. It is not a satellite. It is a ground-based radar system. It can measure the cloud formation in a limited area. And that Doppler radar system, you cannot keep it in every place. See, I will show you the image. I will show you the image of the Doppler radar. See, this is the Doppler radar. This Doppler radar you are placing at one place. It can give you a cloud formation idea about a specific region. Length and breadth in India, we cannot mount this. It is very costly also. On specific locations, we can mount. But the problem with cloudburst is the cloudburst happens in a short span of time. In 30 minutes, cloud will be formed. For 1 hour, the cloud will be floating. So in 1.5 hours, the cloud will be formed. Cloud floating will be completed. In 20 minutes, it will drop. So maybe you can have a 1.5 hours prediction. That is why cloudburst becomes very challenging. And this cloudburst, when it is associated with landslides, it becomes even more disastrous. Okay. And also, see, today the temperature is rising. Global warming, it is said that for every 1 degree rise in the temperature, with every 1 degree rise in temperature, the moisture in the air particle size can be increased by 10%. 1 degree temperature increases, the air particle size can increase by 10%. So we can expect frequent cloud bursts in future. Chennai experienced cloud burst in 2015. Mumbai experienced cloud burst in 2005. Uttarakhand, Himachal Pradesh, these you need not say every year you will experience cloud burst. Okay, so don't think that cloud burst will be always associated with that orographic lift. Don't think that should be always there should be a mountain, so that there is going to be a lift. Mountain will help in lifting the clouds, but even if there is no mountain, when there is high temperature and more moisture, that can also result in cloudburst situation, like what happened in Chennai in 2015. Okay, so why cloudburst was in news? Whatever I have discussed, I have given here. You can go through. You will understand. So Himachal Pradesh experienced cloudburst. That's why it was in news. So will we see more such cloudburst? Definitely we will see. For every 1 degree Celsius rise, we can see increase in moisture by 7 to 10%. That relationship is given by a geography model called as Clausius-Clapeyron relationship. You need not remember this. Maybe geography optional students, maybe you might be knowing it. I do not know. It's a model, okay, which gives this relationship. Just remember this relationship, that is sufficient. This you remember, that is sufficient.